Choosing the right embedding model is a crucial step in developing an effective RAG-based application. A good embedding model is expected to retrieve the right context passages even if the keywords don't match in the query and the target context passages. So, how do we choose the right embedding model? Going with the premium offerings from OpenAI or other API-based services may not always be an option if cost and data privacy are a concern. So in this video, we'll be exploring some popular embedding models available in Hugging Face. We'll also compare their performance with respect to OpenAI's embedding models. Here are the embedding models that we'll be covering in this video. Among them, BG-small-en is the smallest model with 33.4 million parameters and embedding dimension of 384. On the other hand, Stella 1.5b En is the largest model with 1.5 billion parameters and default embedding dimension of 1024. OpenAI's embedding models, just like the line of LLMs, are considered state-of-the-art. So, we'll be comparing the embedding model's output with that of OpenAI's text embedding 3 large and text embedding 3 small. Most of the embedding models that we are comparing requires usage of query prompts on retrieval. So, we'll also compare the effect of using or not using the query prompts. This is how we'll be carrying out the experiment. A technical document of a product is split into multiple chunks using recursive text splitter. Each time, we'll be using a different embedding model. Let's imagine a scenario where the total number of chunks is 8. For a given query, when text embedding 3 large is used as the embedding model, the retriever returns chunk 3, chunk 4, chunk 8, and chunk 1. When text embedding 3 small is used as the embedding model, the retriever returns chunk 2, chunk 3, chunk 5, and chunk 7. On the other hand, when a Hugging Face model called embedding model A is used as the embedding model, the retriever returns chunk 4, chunk 3, chunk 5, and chunk 7. So, how did embedding model A perform? It could retrieve two of the same chunks as OpenAI's text embedding 3 large. So, its recall with respect to text embedding 3 large is 2. On the other hand, it could retrieve three of the same chunks as OpenAI's text embedding 3 small. So, its recall with respect to text embedding 3 small is 3. Embedding model A's total score comes to 5. Now let's see how the 9 embedding models are performing with respect to OpenAI's embedding models for a set of 25 questions without using query prompt. Let's get started. We are halfway through, but we can see that gte-large-en is well ahead of the others, closely followed by BG-large and Stella-en 400M. Let's continue till the finish line. Stella-en 400M leads the race, closely followed by Nomic Embed Text and BG Base En. Now let's see if using query prompts makes a difference. We are halfway there, but we can see that this time both GT-large and Stella EN400M are leading ahead of others. BG-large and Stella EN 1.5B are not far behind. Let's see how this race turns out. This time again, Stella EN400M retains the first position, with Stella EN 1.5 coming in the second position and BG large EN coming in the third position. Now the question is, does query prompt makes a difference? Performance of BG small en, BG large en, snowflake-arctic-embed-l, Stella EN400M and Stella EN 1.5B seems to have improved. On the other hand, performance of BG base en, MX by embed large and nomic embed text seems to have degraded to some extent. Now let's try to visualize their performance with respect to their size and their embedding dimension. Using query prompt seems to have increased the spread or the variance of their scores. This is due to the fact that some models performed really well after using query prompt, but on the other hand, it degraded to some extent for some models. There is an overall positive relationship between the model size and their performance. Stella EN400M and gte-large-en are the two models which strikes perfect balance between size and performance. This concludes today's video. In the upcoming videos, we'll keep exploring new embedding models. We'll also explore other factors which may affect an embedding model's performance. So that's it for today. See you in the next video.